So we're looking at beta oxidation of fatty acid. Beta oxidation of fatty acid. Now, you agree with me that we have 4 macromolecules, right? Carbohydrates, what again? Lipids, proteins, and what? Nucleic acid. So lipids is one example, or one, it falls under the macromolecules. Now, if you break down lipids, you have 2 major things. What and what? Fatty acid and what? Glycerol, right? If the alcohol present was glycerol. Now, our interest here is in the fatty acid. So after digestion of lipids, and we've gotten fatty acid, and the fatty acid have been transported, have been absorbed from the intestine into the bloodstream. What then happened to the fatty acid in our bloodstream? That is where beta oxidation comes in. So the fatty acid can be broken down, stepwise breakdown of the fatty acid. So beta oxidation is just the breakdown of the fatty acid. Do you understand that? But now we want to look at the step-by-step process of the breakdown of the fatty acid. Now first, that fatty acid, the fatty acid undergoes activation first. So the fatty acid is activated. And how is it activated? Now, let's look at this. If this is your cell, here is your nucleus. This open space here is what? Cytoplasm, right? It's a cytoplasm. Good. And there's a fluid inside the cytoplasm called cytosol. True or true? There's a fluid here called cytosol. Now, the first step of beta oxidation of fatty acid takes place in the cytosol. But the main reactions of beta oxidation take place in the mitochondria. Remember, I used to say mitochondria is the powerhouse of the cell, right? Because energy is generated there. And beta oxidation generates energy. Now, first, the fatty acid. This is the fatty acid. The fatty acid is in your cytosol. But first, the fatty acid needs to be activated. And what are we using to activate it? What are we using to activate it? No, that's the enzyme catalyzing the reaction. Now first, fatty acid is activated to fatty acid-CoA. And you're hearing fatty acid, fatty acid-CoA. What comes to your mind? What are we adding? Coenzyme A, right? Coenzyme A. So we're using coenzyme A to activate it in the presence of ATP. So the first step in beta oxidation is what? Activation of what? Fatty acid. And we are activating it to what? Fatty acid-CoA. Good. Now after the enzyme catalyzing that reaction is acid-CoA synthetase or thiokinase. Now at this point we've gotten fatty acid-CoA, right? Where is the fatty acid-CoA? Is it in the cytosol or the mitochondria? It's in the cytosol, right? Good. The next step is the transport of that fatty acid-CoA from this cytosol into the mitochondria. Are we following? But there is a problem here. The first step, we activate fatty acid to what? Fatty acid-CoA in the cytosol. But that breakdown is supposed to take place in the mitochondria. So the second step is to transport the fatty acid-CoA from this cytosol into the mitochondria, right? But the problem here is that the walls, the membrane of the mitochondria does not allow fatty acid-CoA to pass through it. So fatty acid-CoA cannot pass through this mitochondrial membrane into the mitochondria. So fatty acid-CoA now stand, I was looking and say, since this person is not allowing me to enter, since the mitochondrial matrix, the walls, the membrane is not allowing me to enter inside, I really need to get into this membrane so I can have money, I can have energy, I can produce energy. Is it not? So fatty acid-CoA now sat down and think, what do I do to get into the mitochondrial membrane? Said, okay, I remember a transport company that can transport me. So I'll just enter their vehicle and they will not even know I'm inside the vehicle until I get inside. So the second step is transport of fatty acid-CoA into the mitochondria. And since the mitochondrial matrix is impermeable to fatty acid-CoA, we need a transporter. And the transport system we use is called what? Carnitine acyltransferase 1. Carnitine acyltransferase 1. Now, look at this. This is the fatty acid. The first step is activation, right? And it is activated to what? Fatty acid-CoA. Good. Now, the fatty acid-CoA needs to get into the mitochondria, but this wall is impermeable to it. But there is a transport system that is located on the cytosolic phase. This place, there is a transport system located here. So, this fatty acid-CoA will now bind to that carnitine acyltransferase 1 to form what? Acyl what? Carnitine. To form acyl carnitine. Now, as it forms acyl carnitine now, it will walk majestically. Walk majestically through the mitochondrial membrane into the mitochondria. Now, fatty acyl carnitine is now into the mitochondria, right? Remember the first step. The first step is activation of fatty acid to what? Fatty acid-CoA. This is happening in the what? Cytosol, right? We need to transport it to the mitochondria. But the walls of the mitochondria are impermeable, right, to it. So what do? We attach it to what? Carnitine. And the transport system transporting it is what? Carnitine acyltransferase 1, which is located on the surface of the mitochondria. So the fatty acid-CoA will now attach to the carnitine. And as it attaches to the carnitine, it will form fatty acid carnitine. Now, it is now inside the mitochondria. The second step is now I've said the acyl carnitine is transported into the mitochondria, right? Then I've said also that the acyl group is transferred to CoA in the mitochondrial matrix. Now let me explain. If you notice what we have here outside the mitochondria, that is in the cytosol, is fatty acid-CoA, right? Is it not? Fatty acid-CoA. But by the time it's binding to carnitine, the CoA group, the coenzyme A, is not following it. The coenzyme A is left in this cytosol. So it is only the fatty acid group that attaches to carnitine to form what? Fatty acid carnitine. Now the fatty acid carnitine now gets into the mitochondria as fatty acid carnitine. Now back into the mitochondria. Remember the transporter, if you are entering a shuttle and they drop you in Delta Park, the shuttle will return to Abuja to carry some persons, right? Now the shuttle here is carnitine, is it not? Now as carnitine carries the fatty acid group into the mitochondria here, the next thing it will do is the carnitine will now return back to go and carry more, and coenzyme A will now attach to it. Some coenzyme A were present inside the mitochondria. So coenzyme A will attach to the fatty acid group to form what again? Fatty acid-CoA. Now if you notice very well, fatty acid-CoA was once outside, but fatty acid-CoA with sense is now inside. Do we understand that? So we've said two things here. In beta oxidation, the first step is activation of fatty acid to what? Fatty acid-CoA. Now we want to transport the fatty acid-CoA from the cytosol into the mitochondria. But we said there is a problem. The walls of the mitochondrial matrix is impermeable to fatty acid-CoA. So fatty acid group attaches to what? Carnitine acyltransferase 1 to form what? Fatty acid carnitine. So that with that now it will be transported into the mitochondria. And then once into the mitochondria, carnitine will say, I've done my work. It returns back to the surface to pick more fatty acid group. Then fatty acid group now, here inside now, we now look for its person, CoA, and they bind again. Fatty acid-CoA is reformed. Once fatty acid-CoA is reformed, the last reaction of beta oxidation can now take place. Remember, we said beta oxidation, we want to break down the fatty acid, right? Now the fatty acid in the form of fatty acid-CoA is now in the mitochondria where it's supposed to be broken down. So the last step is reactions of beta oxidation. Now that the fatty acid CoA is in the mitochondria now, there are 4 steps. There are 4 steps involved in the breakdown of that fatty acid. There are 4 steps. The first step there is the fatty acid. Can I clean this side? Can I clean this side? Now, what is going to happen is the fatty acid now, the fatty acid CoA inside the mitochondria, fatty acid CoA will be oxidized by FAD. So the first step inside the mitochondria now is oxidation by what? By FAD. So it will be oxidized to delta 2 trans-enoic CoA. Let me explain what that means. If we have fatty acid CoA, let me draw the structure. If you agree with me that this fatty acid, right? In our previous class, we've learned fatty acid in details. Now this fatty acid. Now, if you look at this structure of fatty acid, if this arrow represents the alkyl chain, right? I don't want to complete the alkyl chain. If you notice, if I write it this way, I've not changed anything, have I? I've not changed anything, it remains the same. Now, if I attach coenzyme A, coenzyme A is always attached with a sulfide bond. So this is coenzyme A attached. What I now have on the board is what? This structure on the board is now what? Fatty acid CoA, right? Fatty acid CoA. Now this is the fatty acid CoA in the mitochondria. The first step is oxidation by FAD. You agree with me? This is the carbonyl carbon, right? The functional group. The carbon after the functional group is called the what? Alpha carbon. The next one is what? Beta carbon, right? Good. Now, an enzyme called what? An enzyme called what? What's the name of the enzyme catalyzing this reaction? What's the name of the enzyme? You'll be the one to tell me the name of the enzyme. Let me explain the reaction and you tell me the name of the enzyme. Now, the oxidation, you agree with me that oxidation is addition of oxygen or removal of what? Hydrogen, right? Good. Now, if you look at this is carbon 1, right? Carbon 2 and carbon 3. FAD will come here and remove one hydrogen from carbon 2 and carbon 3. So one hydrogen will be removed here, another hydrogen will be removed here, and to complete the carbon, you see that a double bond will be introduced here, right? That is the reaction by FAD. So what am I doing? I'm removing hydrogen, right? So what do you think the name of the enzyme will be? Dehydrogenase. Dehydrogenase, removing hydrogen. All right. Now, if that is the case, yeah, you observe that if hydrogen is removed, we already have a double bond between carbon 2 and carbon 3, right? The name of this structure, the name of this compound form is called delta 2 trans-enoic CoA. Now, if you look at this, Why is it delta 2? Double bond is on carbon 2, right? Is it not? Good. Now, oxidation by FAD, what we've said so far is the first step in beta oxidation is what? The first step is activation of fatty acid to what? Fatty acid CoA. Then after that, we need to transport the fatty acid from the cytosol to the mitochondria, right? But we said it cannot pass. So the fatty acid CoA will combine with carnitine to form what? Fatty acid carnitine. The fatty acid carnitine now travels. All right. So we say the first step is The fatty acid is activated to fatty acyl-CoA, right? Now, after the activation, we need to transport the fatty acyl-CoA to the mitochondria, but it is impermeable to it. So the fatty acyl-CoA binds to carnitine to form what? Fatty acyl-carnitine. The fatty acyl-carnitine now moves into the mitochondria, and in the mitochondria, the carnitine drops the fatty acyl group and returns back to the surface of the cytosol. Now, inside the mitochondria now, the fatty acyl group combines with what? CoA to form fatty acyl-CoA again. Now, inside the mitochondria, the breakdown wants to take place. And the breakdown, which is the reactions of beta oxidation, have 4 steps. The first thing that will happen is once the fatty acyl-CoA is formed inside the mitochondria, FAD will say welcome. FAD will come here and oxidize this fatty acyl-CoA, and you agree that oxidation is removal of hydrogen, right? So FAD will come and remove one hydrogen from carbon 3 and one hydrogen from carbon 2, and a double bond is introduced. That is trans-enoic-CoA is formed. Now, after that, the next thing is hydration. Hydration means what? Hydration means what? Hydration means addition of what? Water, right? Addition. Addition of water. You're adding water. And water is what? H2O, right? Is it not? H2O or HOH, right? Now, this HOH is added across these bonds to remove the double bond. To remove the double bond. Now, one hydrogen, is this the alpha carbon or the beta carbon? Alpha or beta? Remember, the carbon immediately after the carbon, the functional group carbon is the alpha carbon, right? So this is the alpha carbon and this is the beta carbon. Now, the hydrogen is added to the alpha carbon, so we now have 2 hydrogens here. The OH is added on the third, so we have this. Now, at this point, this OH, is it on the beta carbon or alpha carbon? Beta carbon, right? That is why the product form is called beta hydroxy acyl-CoA. Beta hydroxy, because the hydroxy group is on the beta carbon. Beta hydroxy acyl-CoA. Do we get that? Now, after the beta hydroxy acyl-CoA has been formed, the name of the enzyme catalyzing this reaction is hydratase. Hydratase, an enzyme adding water. After this has been formed, the next step is another oxidation. Oxidation by NAD. Now, if we oxidize NAD, oxidation, just like we said, is either addition of what? Oxygen or removal of what? Hydrogen. Now, if you notice, if you oxidize alcohol, you have what? If you oxidize secondary alcohol, what do you get? No, if you oxidize primary alcohol, you get an aldehyde, right? If you oxidize secondary alcohol, you get what? Ketone, right? Ketone. Now, NAD will now come and oxidize this. Will now come and oxidize this to a ketone functional group, resulting to the compound beta keto acyl-CoA. Beta keto because the keto functional group is on the beta carbon, right? So we've gotten beta keto acyl-CoA. Now the last step. The last step. After forming this, an enzyme called thiolase will come and break this bond. Pap. As it breaks this bond, look at this thing form. This structure on the body, this is what? Acetyl what? CoA, right? Acetyl CoA will be given up. And we have fatty acyl CoA that is 2 carbon less than the original one we started with. So acetyl CoA is given up. Acetyl CoA can go into the TCA cycle, is it not? To release energy. This fatty acyl CoA returns back, and the fatty acyl group returns back, and the process is repeated. Another step, we remove 2 carbon as acetyl CoA. The fatty acyl group will still return back, and we'll be breaking by that, removing 2 carbon at a time until we finish everything. So let me recap this. Then, after recapping, we'll take a practical question. We'll take one fatty acid and we break it down to see what is really happening. But now, you said, can it be drawn as a cycle? No, it's from here that the cycle enters. Because this is fatty acid group now. So from here, that's where the cycle enters. Yes. This step 3 here, that is where the cycle enters. You know, this one I stop at step 1 and 2. Now, basically what I've said here is this. For us to break down fatty acid in beta oxidation, there are 3 steps. And step 1 is what? Activation of what? Of fatty acid. Step 2 is what? Transport of the activated fatty acid, right? And step 3 is what? Reaction of what? Beta oxidation. So step 1, fatty acid is activated to what? Fatty acid-CoA. And now the fatty acid-CoA has been activated. We want to transport it to the mitochondria. But we say the walls of the mitochondria is impermeable to it. So we need a transporter. And the transporter we use is what? Carnitine acyltransferase 1. Now the carnitine acyltransferase 1 transports, binds to the fatty acid group to form what? Fatty acid carnitine. The fatty acid carnitine now gets into the mitochondria and the carnitine is released back. Then the fatty acid group combines with CoA to form what? Fatty acid-CoA. Now once we get our fatty acid-CoA, the fatty acid-CoA will now undergo the last stage, which is the reaction of the beta oxidation. And we said once fatty acid-CoA is formed, the first thing, FAD, we oxidize it, introducing a double bond, right? After we've introduced a double bond, hydration will now take place. We add hydrogen and OH. OH will now be on the beta carbon, right? After that hydration, NAD will now come and oxidize that OH to give us a ketone functional group. Then after that, we break to form acetyl-CoA and fatty acid-CoA, and fatty acid group is given off. This explains beta oxidation of fatty acid. So we are going to take a practical example. You said? No. Now, if you look at this, this is the first 2 steps of the reaction. Fatty acid is converted to fatty acid-CoA. It moves inside as fatty acid carnitine. Carnitine is given off. We have fatty acid-CoA. Now, as the fatty acid-CoA is formed, the fatty acid-CoA now undergoes the first reaction, which is oxidation by FAD. So FAD oxidizes it by adding a double bond between carbon 2 and 3 to form enoic-CoA. Water is added, hydration, and the OH of the water is added on the beta carbon, right, to form beta hydroxy acid-CoA. Next is that OH is oxidized to a ketone group to form beta keto acid. Then tyolysis or cleavage. This beta keto acid-CoA is now broken down. Coenzyme acetyl-CoA is given off. Coenzyme A combines with the fatty acid group that is left to form fatty acid-CoA that is 2 carbon less than the original one we started with. So it continues the cycle, and the acetyl-CoA goes into the TCA cycle to generate energy. So basically, this is it.